Hello guys, this is Rekha from Sri Venkateshwara College of Engineer. Subject is ATC, subject code 21CS51. Today my topic is Deterministic finite automata. Introduction to Deterministic finite automata. Deterministic finite automata DFS are mathematical models used to represent and analyze the behavior of the systems that can be in a finite number of the states. And DFS are widely used in the various fields including computer science and artificial intelligence. And DFA consists of states, transitions and an initial state that can accept or reject input strings based on the defined rules. Next, we'll discuss about the components of deterministic finite automata. Here the example is construct the DFA that accepts any string over a comma b that does not contain the string AABB. Is it summation is equals to a comma b. States DFS have the finite set of the states which represent the different configurations or conditions of the system. Next, transitions. DFS have the transitions between the states which are triggered by input symbols from a specified alphabet. Next is initial state. DFS have the initial state from which the evaluation of the input strings begins. Next, the transition function and input alphabet. Transition function. The transition function defines the rules for moving one state to the another based on the input symbols. It maps a state and an input symbol to a new state. Next is input alphabet. The input alphabet is a finite set of the state that can be used as the input from the automaton. Each symbol, the alphabets trigger transition from one state to the another. Next, we'll discuss the applications of the DFA. First is language recognition. One of the most common applications of DFA is in recognizing of the formal language. DFA can be designed to recognize a specific language such as programming language or a markup language by the specifying the set of acceptable strings in a language. Second one is compiler design. DFS are used to design a compilers which are programs that translate source code written in a programming language into machine code. Compilers used to DFA to scan the source code and identifying the various tokens such as keywords and identifiers that make up the languages. Third one is testing processing. DFS are used in a testing processing applications such as spell checkers and text editors, the recognizing patterns in a text and perform the specific actions based on those patterns. Next application is fourth one, network protocols. DFAs are used in the design of the network protocols such as TCP and IP to the specific the sequences of the events that must occur during the communications between two devices. Next, fifth is Linuxal analyzing. DFS are used to Linuxal analysis, which is a process for breaking down a stream of the text in individual words, phrases, and other elements. Next, sixth is cybersecurity. DFS are used in the cybersecurity to detect the prevent malicious activities by the recognizing patterns in a network traffic. Next, seventh is pattern matching. DFS can also be used to match regular expressions in a text, which is common task in a text processing and data mining. Next, eighth is automated testing. DFS are also used in automated testing in check from the specific input sequences and respond accordingly. These are the applications of the DFS. Next, acceptance of the input strings. Acceptance by the final state. A DFA accepts input string. It reaches to the accepting state after the processing entire string. Next is the rejection by the final state. A DFA rejects an input string if it does not reach any accepting state after processing the entire string. Next is non-deterministic transition. If a DFA encounters a non-deterministic transition, non-defined a transition for a given input symbol, it rejects the input string. These are the acceptance of the input strings. Next, we'll discuss about the deterministic versus non-deterministic automata. First, we'll discuss about the deterministic automata. In deterministic automaton, for each state and input symbols, there is exactly one transition defined in the transition function. Next, we'll discuss about non-deterministic finite automata. In a non-deterministic automaton, there can be multiple transitions defined for a state and input symbols. These are deterministic difference between deterministic and non-deterministic automata. Next, we will discuss about the language recognition. First, language. In the context of DFS, a language is a set of the strings that can be accepted by the automaton. Next, language recognition. DFS are used to recognize or determine whether a given string belongs to specific language or not. Next, regular language. DFS can recognize regular languages, which are the class of the languages that can be described by the regular expressions. These are the languages. Next, deterministic finite automata example. We'll discuss about example. Let's consider the DFA that recognizes the language of all binary strings that ends with A1. States. The DFA has the two states labeled by Q0 and Q1. Transition. For each stage, there is a transition defined for input symbol 0 and 1. Next, final conclusion. Deterministic finite automata are the valuable mathematical models for analyzing and recognizing languages. Their simplicity and efficiency make them widely used in the various fields. Understanding the components, rules, and applications of DFAs or provide insights into language recognizing and problem solving in the many domains. Thank you.